dear students, this is the question for today's video. Basically, in this question, we are being asked to to calculate the magnitude of the electric field that is produced by these two charged particles at this point P. So, we know the formula for electric field is given by E equals to KQ over R square, where K is constant, Q is the magnitude of the charge, and R square, this is the distance between the charge particle and the point at which we have to find out the electric field. So in this case, from this point to this point, means from this charge to this point, this is the distance R, this distance R. Okay students, so now after the equation, what we have to do is we have to point out the direction of the electric field that is produced by this charge over here and by this charge over here. So for the direction, we need to recall that the electric field produced by a positive charge particle, the direction of such field is away from the charge particle, and the electric field that is produced by a negative charge, the direction of such field is towards the charge particle. So since this is a positive charge particle, the electric field produced by this positive charge particle will be away from this charge particle. So if I draw the direction of this charge particle here at the point P, it will be away from the charge particle, so the direction will be here, so arrow head will be here. And now if I produce, or I say if I draw the direction of the electric field that is produced by this negative charge particle, so the direction will be towards this charge particle because it's negative, so it will be like this. So students, this let's call this one charge particle Q1 and this is Q2, so the field produced by Q1 is E1 and this is produced by Q2, so this is E2. Okay students, now what we have to do is we have to divide this E1 and E2 into their components, because we know that electric field, it's a vector quantity, and because we have to find out the magnitude of the electric field. So how can we find out the magnitude? We can simply add up x components and y components together and find out the total magnitude of the electric field that is produced by these two charged particles at the point P. So for that we have to split these into the component. If I split E1 into its component, the first component will be here like this, and the second component, y component, will be here like this, and the directions will be like this according to head and tail rule. Similarly, for charged particle E2, when I say charged particle, I refer to these both charges. Okay, fine, students. So here at point E2, the first component will be like this and the second component of E2 will be like this. So now students, it is clear from the diagram that since these two fields have opposite direction, so they will cancel out each other. So we will be left only with the y component of E1 and with the y component of E2. So we can say that we have only two electric fields that are produced by these two charged particles at point P, or we can say two components. First component is E1, and because this is theta here and this is theta here, so it's opposite to the angle, so it is sine theta. Similarly, for this, it is opposite to the angle, so we can say that it is also sine theta, so that is E2 sine theta. So if I say that the total electric field that is at this point P, if I want to write the total electric field, I can say that summation of E, that is total electric field, is equals to E1 sine theta plus E2 sine theta. Right students, because x components are being cancelled, both x components have been cancelled, so we will not take them in our calculation, we will only take y components. So now students, what we have to do is we have to plug in the value of E1 and E2 from here, this equation. We know that E is kq over r square, so for a charge particle 1 we will write k q1 over r. For a certain reason, I'm calling this distance r dash. Okay students, you will come to know the reason later. So it will be r dash square plus for E2 it will be sine theta, plus for the E2 it will be k q2 over r dash square sine theta. Now students, focus that both charge particles have the same magnitudes, means q1 is equals to q2. So these two terms are like terms, means these are the same terms. Similarly, this is the distance r dash. This distance is actually from charged particle to the point at which we are calculating the electric field. So this is basically this distance right here from Q to this, and this is basically this distance from first charged particle to point P. So if you see, these two distances are the same distance. The distance from here to here and the distance from here to here will be same. So means the distances are same. And also sine theta is same and k is constant. So it's mean that these two terms are like terms. So we can add them collectively. So if I call it x and call it also x, so x plus x is 2x. So similarly, if I say kq1 sine theta over r dash square plus kq2 sine theta over r dash square, if these are the like terms and we add them, so it will be 2k. And for q1 and q2, because these are like terms, so I can collectively call them q over r dash square and sine theta. Okay students, I have added them because they were like terms. So now what we have to do is we have to find out, to solve this equation, we have to find out this distance r, that is the distance between charged particle and point where we have to find out the electric field. So this is basically the distance which we have to find out, and I have called the distance r dash. Why I have called the distance r dash? Because if you see, from this to this distance we are given r distance in the question. So you will get confused by this. If I have taken it r, you will get confused by same distances. These are basically not the same distance. This is the r distance which is given to us in the question, and this is the distance which we have to find out, which I have called r dash. This was the reason I have called it r dash, so that you can differentiate between these two distances, right students? So now if you see, these are basically two right angle triangles and they have the same nature. If I take only one triangle and solve on it, the second triangle will have the same calculations. So I am taking only this triangle right here, and by this triangle I will get this r dash square. Okay students, so if I take this triangle separately and draw it over here, it will be somehow like this: d by 2, this distance, then this distance that we have called r dash, and then this that is given to us r in the question. So students, you can see that here it is also a right angle triangle and we have theta over here. So now if I have to find out this r dash, I can simply apply Pythagoras theorem and find out. So if I apply Pythagoras theorem on it, it will be hypotenuse square is equals to base square plus perpendicular square. So it will be r dash square, that is my hypotenuse, is equals to base square, that is r square, plus perpendicular, that is d by 2 ka square. Right students, and if I have to find out only r dash, I can take under root on both sides. So it will be r dash is equals to, by taking under root on both sides, it will become r square plus d by 2 whole square. Sorry, this is this r. Right students, so now what I will do, I will take this whole term, I will take the value of this r dash and put it in this equation. So my equation will become summation E is equals to 2kq sine theta over, instead of r dash I will put the value of this r dash, that is here, under root of r square plus d by 2 whole square and square on it. So it is complete square. So now this square will cancel out by this root. So we will be left with 2kq sine theta over r square plus d by 2 whole square. So students, now what we can do is we know the value of this 2, it's a constant, obviously we know the value of q, it is the magnitude of the charged particle given to us here in the question. We know d, we know r, like we know all the terms here, but we don't know sine theta. So what we have to do is we have to remove this sine theta. How can we remove sine theta from this right angle triangle? We know that sine theta equals to perpendicular over hypotenuse, so we can apply it over here. Means if I want to put the value of sine theta here, that is perpendicular over hypotenuse, the value will be perpendicular d by 2. We know the value of d, 2 is a constant, so over hypotenuse, that is r dash, we know the value of both, so we can put d by 2 over r dash instead of sine theta. Means what I want to say is, we know sine theta equals to perpendicular over hypotenuse. Perpendicular is d by 2, so it is d by 2 over hypotenuse, that is r dash. So just simply put it over here, and instead of r dash, put the value of r dash, that is this. Okay, so students, if I do this, I will get 2kq over, write this as it is, r square plus d by 2 whole square, and instead of sine theta, put this value, that is d by 2 over r dash, the value, put the value of r dash, that is under root of r square plus d by 2 whole square. So now students, this 2 will get cancelled by this 2, and in numerator we are left with kqd over. If you consider the denominator terms, these are the same terms, like it is completely, it has power 1, and completely it has r square plus d by 2 whole square, and it is also r square plus d by 2 whole square. It has power 1 and it has power 1 by 2. So if I add up these two powers, 1 plus 1 by 2, it will be 3 by 2. So you can write r square plus d by 2 whole square, and whole power is 3 by 2. Now in this equation you have all known values. You only have to put all these values in your calculator and find out the answer. So let's put all the values. We know k is a constant, so its value is 8.99 exponent 9. Similarly, q is given to us in the question, that is 4.45 exponent minus 6. Similarly, d distance, it is also given to us in the question, that was 2.19 exponent minus 6 over r square. Students, in the question we are given r in centimeter, we have to convert it in meters, so it will be 9.86 exponent minus 2 meter. Okay, so we will put this in standard unit. So it will be r, instead of r, put the value in meter, that is 9.86 exponent minus 2 square plus d. D is given to us in the question, that was 2.19 exponent minus 6 over 2. It has square complete square, and this whole term has power 3 by 2. Now substitute this whole equation in your calculator very carefully, and you will get approximately 91.4 Newton per coulomb. So student, this was the question for today's video. I hope the question is clear to you. If you have any query, you can ask me in the comment section. Plus don't forget to subscribe the channel, and if you found this video helpful, share with your friends also.